Hi there, and welcome to this video on A-level chemistry for the AQA specification, focusing on the topic the amount of substance, and in particular on empirical and molecular formula. Hi, I'm Manisha from StudyMind, where we help you to revise A-level chemistry with our helpful revision resources tailored to your subject, your specification, and to you. If you're new here, please make sure to click that subscribe button, and whilst you're watching, please leave any comments down below about anything you're unsure of. If it's your first time watching, make sure to let us know so we can send you our free revision resources. We also have helpful timestamps to guide you through the video. So, let's get started. Welcome to lesson 4 of 5 in this tutorial, covering empirical and molecular formula. This is the fourth in our series of 5 tutorials on the topic amount of substance. In the last lesson, we learnt about the ideal gas equation and put it to use in some calculations. Here are our key learning objectives for this session. First, we will go through the difference between empirical and molecular formula, then work out molecular formula from empirical and MR, then look at how to calculate the empirical formula from percentage composition by mass, and finally we will calculate the empirical formula from percentage by mass. Here are the AQA specification points for this tutorial. There are quite a few listed here, so make sure you pause the video now and read through them before we begin. We'll start off by looking at the definitions for empirical and molecular formula. We'll be looking at 3 definitions in this section. These are empirical formula, molecular formula, and empirical mass. The molecular formula is the actual number of atoms of each element in a compound. Let's look at an example. Hydrogen peroxide would have the molecular formula of H2O2. This is the molecular formula since it is the actual number of atoms of each element in this compound. In contrast to this, the empirical formula is the simplest whole number ratio of atoms of each element in a compound. Let's take hydrogen peroxide again. The molecular formula we've just seen is H2O2, whereas the empirical formula would simply be HO. The empirical mass is the total mass of all the atoms in the empirical formula. Next, we'll be looking at the relationship between empirical formula and molecular formula. A certain number of empirical units will make up the molecular formula. We've just seen that hydrogen peroxide has a molecular formula of H2O2 and that the empirical formula is HO. This means that the simplest ratio of hydrogen to oxygen atoms would be 1:1. Let's fill in this table as a summary of the empirical formulas we have just learned. We'll start off with the element water. This will have a molecular formula of H2O. Its empirical formula is also H2O. Next, we'll look at glucose. This has a molecular formula of C6H12O6. Its empirical formula is CH2O. Next, we'll look at hydrogen peroxide. This has a molecular formula of H2O2 and an empirical formula of HO. Butane is the next one that we'll look at. This has a molecular formula of C4H10. The empirical formula will be C2H5. Finally, we will look at benzene. This has a molecular formula of C6H6. This means its empirical formula will simply be CH. Pause the video now to have a go at filling in the blanks yourself. This is a good revision exercise and will help you to convert between molecular formula and empirical formula. Knowing how to convert from molecular to empirical formulae are quite important. In science, we tend to use molecular formula more, but empirical formula helps us to understand the ratios of elements in certain compounds. It's also important that you remember that a compound contains one or more elements. A molecule will contain one or more types of atom. We've now covered the first two specification points. Our next one will deal with calculating the molecular formula. You may be asked to calculate the molecular formula from the empirical formula and the relative molecular mass. Let's have a go at this practice question. Pause the video now to have a go at it yourself before we attempt it step by step. The molecular formula is C6H12O6, or glucose. Now let's work through it together. Our first step is to work out the empirical mass of the molecule. This means that we would do 12 plus 1 times 2 plus 16. This gives us a value of 30. Now we will divide the molecular mass by the empirical mass. We should look at the MR we're given in the question and compare it with the empirical mass we calculated in step 1. We can compare the values by dividing the MR by the empirical mass, and the value you achieve will tell you how many empirical units make up the molecule. So to do this, we would do 180, which is what we're given in the question here, and divide by 30, which is what we worked out here. This is going to give us an answer of 6, which means there will be 6 empirical units. Finally, to calculate the molecular formula, we will multiply the empirical formula by the number of empirical units found in the molecule. So in this instance, we would do CH2O multiplied by 6, and this gives us an answer of C6H12O6, or glucose. We've now completed almost all of the specification points for this lesson. Let's look at the final two together, which cover the calculations of empirical formula. You can calculate the empirical formula of a molecule from the percentage composition by mass of elements or the percentage by mass of elements. Again, let's look at a practice question. Pause the video now to have a go at it before we go through it step by step. The answer to this question is C4H10O. Let's work through it together. The first thing we have to do is change all the percentages to grams and assume 100 grams of the compound is present. So to do this, we would say that carbon, we were given a value of 64.8%. So this would become 64.8 grams. It's the same thing for hydrogen and oxygen. So hydrogen was given to us as 13.62%. So we make this 13.62 grams. And for oxygen, we were given a value of 21.58%. So we make this into 21.58 grams. We now need to use the equation that was introduced to us earlier. This equation is the number of moles is equal to the mass over the MR. Now we can use our values from step 1 to work out the number of moles. So if we wanted to work out the moles of CH, this would be 64.8, which we worked out here, divided by 12, which gives us an answer of 5.4. Moles of H would be 13.62 divided by 1. And also the moles of oxygen. So this would equal 21.58 divided by 16, which equals 1.349. Finally, we can find the empirical formula by dividing the number of moles of each element by the lowest number of moles. In this case, oxygen has the lowest number of moles at 1.349. So in this case, what we'd do would be to write carbon would be 5.4 divided by 1.349, which gives us a value of 4. Hydrogen would equal 13.62 divided by 1.349, which gives us a value of 10. And oxygen
which is 1.349 divided by 1.349, which gives us a value of 1. Therefore, the empirical formula must be C4H10O. By dividing by the lowest number of moles, we are setting up a ratio. Normally, the calculations will work out nicely to whole number ratios. If you get any halves, then just multiply by 2 to get to the whole numbers, as shown here. If they give you AR or MR values in the question, it usually means you have to use them. Recheck your method if you forgot to use them. Since this is one of the trickier calculations to perform, let's attempt another practice question before we end the video. This question is about a hydrocarbon. Remember, a hydrocarbon is a compound that only consists of the elements carbon and hydrogen. The answer to this question is CH4, or methane. Let's see how we got to this answer. Firstly, we must calculate the number of moles of each of the products CO2 and H2O. We need to use our number of moles equation here. So this would be moles is equal to mass divided by MR. Now, we can work out the MR of carbon dioxide and water, and the number of moles as well. So let's start off by working out the MR of CO2. This would be 12 plus 16 times 2, giving us an answer of 44. Our MR of H2O is going to be 1 times 2 plus 16, giving us an answer of 18. Now we can work out our moles. So our moles of CO2 are going to be equal to 4.4 divided by 44, giving us an answer of 0.1. And our moles of hydrogen, our moles of water is going to be 3.6 divided by 18. Next, we can work out how many moles of carbon and hydrogen atoms there are found in the hydrocarbon. So in 1 mole of CO2, we would find 1 mole of carbon atoms. However, in 1 mole of H2O, we will find 2 moles of hydrogen atoms. Therefore, we can do 0.1 times 1 to give us 0.1 carbon atoms. And 0.2 times 2 to give us 0.4 hydrogen atoms. We can calculate the empirical formula of the hydrocarbon by forming the simplest whole number ratio of carbon to hydrogen atoms in the hydrocarbon. So now we can do our carbon to hydrogen ratio would be 0.1, which was found here, to 0.4, which was found here. This means our empirical formula must be CH4, or methane. We've now completed all the learning objectives for this lesson. If you are unsure about any of the points above, feel free to skip back to that section of the video and watch it. We have now completed Lesson 4.
If you liked this video, make sure to catch our latest videos by subscribing down below and leaving a comment on a topic that you'd like to see a video on. Click here to watch more videos on our series of A-level chemistry, or visit our website studymind.co.uk for past paper compilations by topic and specification.